So let's begin our study of calculus with the question, what is calculus? What are we going to be learning throughout this course? And in particular, how do we describe rate of change? And that's a really important question because if you were to ask me to define calculus in a very simple way, calculus is basically the mathematical study of change. And you've learned some things about change throughout your math career, particularly probably in algebra. If you talk about rate of change, the thing that probably comes up is probably somewhere along the lines you had an algebra teacher who said, oh, rate of change, that just means the same thing as slope. And they did you a little bit of a disservice because rate of change can extend well beyond just the slope of a linear function. So the rate of change really does mean more than just slope. Now then, we equate those two terms in algebra because it's very important for you to understand that these linear functions that you learn at the time have a constant rate of change. But every function, whether it's linear or some other type of function you've now learned, we can describe the rate of change. And so let's just consider, after linear functions, the next major function type you learned was quadratics. And let's just take a look at the parent function f of x equals x squared. Well, if we graph this function, grab a different color here, we have an idea that it looks something, it's a parabola, it has a vertex at the origin, and it looks something like that. And that's one of the things you learn in Algebra 1. Now then, does this quadratic, does this parabola have a slope? No, it does not have this constantly increasing or decreasing rate of change the way that a linear function does. But can we describe some things about the rate of change? The answer is yes. So one of the things that we first look at is we say, hey, this function f of x, it is decreasing right up until we get to this vertex at 0, 0. So we can say f of x decreases on the interval negative infinity to 0. And if you think about what a decreasing rate of change means, it means, a decreasing function has a negative rate of change. And as we actually start to get deeper and deeper into this idea, you'll learn that, yeah, it's got a negative rate of change from negative infinity to 0. Well, we can also say that from 0 onwards, the function is increasing, and so it has a positive rate of change because f of x is increasing on the interval 0 to infinity. And so those are some very important things for us to understand. So this right here, this idea that the function decreases is going to tell us there's a negative rate of change. And when it increases, that's going to tell us there's a positive rate of change. And if we just take a look at the idea of what's happening from 0 to infinity, and we can make some similar statements about negative infinity to 0, but for 0 to infinity, if I take a look at what happens, let's say at the point 1, 1, and then I come over and say, let's take a look at the point 3, 9. Then what happens is the further to the right I go, or the larger the values of x that I'm getting, the rate at which the function is increasing is itself starting to increase. So I can say from 0 to infinity, f of x increases at a faster rate of change as x grows larger. So we can take this idea, this algebraic idea of rate of change, and we can extend it beyond just the slope of linear functions. And a big thing that we're going to be doing in this course is really analyzing some of these statements we made about what we already knew about the rate of change of functions like these.